This will be a practice test. Again, a good idea before you take a test. Make your own or use this one, where it gives you an idea of what the examples will be like. The numbers will usually be different, but the kinds of things would be similar. All right, going on to item number 1. Again, read the question carefully, write it down, then pause. So writing this down, we get a negative 4x squared plus 4x plus 5. And we're asked to substitute for our x value a negative 3. So the protocol for doing something like this would be, again, write it out carefully, negative 4, and then in parentheses you're going to put your x value, which is a negative 3, that you're then going to square, plus 4, and again, parentheses, a negative 3, plus 5. So there it is laid out, and then you're going to do exponents first. So a negative 3 squared is a positive 9. So we have negative 4 times 9. And we could actually start to solve it because the rest is just multiplying. So this will be a negative 36. This is going to be a negative 12. And this will be a positive 5. So again, adding these two together, you get a negative 48 plus 5. And you may be able to eliminate some of the steps here, but again, you want to not lose points on something that's this easy. Your answer is a negative 43. And let's see what they have here. And there it is, a negative 43. Now, for this one of the steps you might eliminate is, instead of writing it, you can just copy it and then do the substitution. So negative 4, parenthesis, but now we're going to substitute a 1 here that we're going to square, and then a plus 4. Again, our x is 1. Put that in parentheses, plus 5. So now 1 squared is 1. Negative 4 times 1 is negative 4. This will be a plus 4, and this is a plus 5. Well, these two will cancel out each other, and our answer is a plus 5. But again, you want to show the work, careful, watching the signs. Let's go on. Now, this is sort of a challenging problem. Again, read it carefully. Find the equation of a line that passes through this point. Now, negative 1, negative 3 is right there. So negative 1, go over 1, and then down 3. That's this point. But you want a line now that is perpendicular to this line. This line is this equation. So the protocol to solve it is to find out, well, what's the slope of a line that would be parallel to this first? So I write it out, and I'm going to transpose the negative 6x to this side, where it becomes a positive 6x plus 15. Divide everything by 3. And now I get it in slope-intercept form. Just for review, y equals mx plus b. Well, b is our y-intercept, which is the 5 here. And that's right there. So that looks good. But what then is the slope of this line? Well, the slope of this line is what would be in the m position, and that's a 2. And remember, that's 2 over 1. We just don't write that. So a line parallel to this would have a slope of 2. But we want to find the slope of a line that would be perpendicular. So we said the protocol for that is to take the slope and the opposite sign, reciprocal of that, would be a negative 1/2. So that's where we are. And the point that we wanted to go through is a -1, -3. So I'll go to the whiteboard now. And what would be the equation then of that line? Well, we're going to use this slope-intercept form and substitute these values, the slope and this x and y value. So the y is a -3. Our slope is a -1/2. Our x value is a -1. And what we don't know is what our new b value would be. Well, to get rid of our fractions, I said that's always a good idea. I'll even change colors here. We're going to multiply everything by the lowest common denominator, 2. Now, there's 3 terms. 1 term, 1 term, 1 term. So 2 times this is a -6. Now here, when we multiply 2 times a -1/2, the 2's cancel out, and we get a -1 times a -1, which will give us a +1. And then this is going to be plus 2 times b is 2b. We're going to transpose our 1 to the other side where it becomes a -1. So this is a -7 equals 2b. Now we're going to divide both sides by 2, and b is a -7/2. So now writing our new equation in slope-intercept form will be y equals, we know our slope is going to be a -1/2 x. Remember, the slope is only the numerical part. The x is just part of the formula. And now we have a new value for b, which is a -7/2. So let's go to our regular thing. Now this person had this equation incorrect. So let's see what's going on here. Now they had written the -1/2 correct, but they didn't get the correct y-intercept. They had 5 halves. So they were given partial credit for this, for having the perpendicular slope correct. Now, if I click on display the answer, and I'm going to clear this up here, it shows, and I got to do it higher here. Let's see here if I get it higher, that the correct answer is indeed a -1/2 x and a -7/2. Okay, lots of stuff here. And the nice thing about something like this is you can go back and, again, try it on your own a little later. Now, in this example, read it carefully. They're asking us to FOIL, but this is a special product. As we look at these, we see these are conjugates. And remember, when you multiply conjugates, the middle terms cancel out. So we just need to multiply our first, which will give us x squared, and our last, which will give us a -4. Now, when we square conjugates, which are the sum and difference of the same terms, the product, we get the difference of perfect squares. So later, when we have to factor the difference of perfect squares, they will factor into its conjugates. That's where we're going in our next unit. And this person had that correct. Now, this one again, you need to know what formula to use. And it's the compounded continuous formula. Continuous interest formula is A, future amount, is equal to the principal times Euler's E raised to the rate times the time. So let's substitute. So A equals the principal is 7925 times Euler's E, and the rate is 7%. We're going to put a caret in there. Now, some of your calculators already include the caret, so you have to know how to do it. So converting this to its decimal fraction times now 17 years. So what you need to do is pause, write this into your calculator, and then see if you get this answer, which is 26050.12. Now, you're going to get more places here. You have to see what's in the third place. If it's 5 or more, you're going to drop this and add 1 to what was there originally. If it's 4 or less, you just drop it and you keep it this way. Now, if you're not exact about this, they're going to count it wrong. But this is where I can give partial credit if you just have a rounding error. All right, let's go on. Reading this carefully, you should pause. All right, now your basic formula is this, 800. Now, since it's 1 plus what's in the parentheses, we can just write it as one term, 1.122. We write that properly here. So combining the 1 and the 1.22 here, or the 122, gave us this. And the time here, the t, or the x, is 54. Just putting this into your calculator, you should get this. And that's 400,593.83. Again, rounding off whatever is needed to the nearest cent. If you don't follow that exactly, they're going to count it wrong. And you should practice this to be sure you know how to use your calculator. Now, for something like this, a protocol might be, again, this is subtraction. So when you have a negative sign in front of a parenthesis, what you do is you get rid of the parentheses but change each of these signs. So I'm going to write that on top actually. So I have a positive 6x squared and a negative 4 now after changing both of these signs. Then I'm just going to put this underneath then. Here you just release the parentheses and you get a negative 2x squared and a plus 7. So the idea of having them in like-term columns I think is helpful. The key is remember to change both signs or all of the signs. So this is going to be 4x squared and this will be plus 3. And they had this right. For something like this, you need to know the rules involved. Here, this part is the product rule. So let's write it big. So keep in mind there's like a little 1 there by the 2. So this would be 3 and this will be the exponent in the powers rule. It's 1 times 2, so this is 2 to the second. M, multiply the exponents to the 6th. Now, 2 to the second is 4, so this is 3 times 4m to the 6th. I'm putting an extra step in it to make it clear. So this is going to be 12m to the 6th. And that's what they have. And of course, you have to simplify, as is indicated by the instructions. All right, let's go on here as the next one comes up. Okay, graph the following equation by plotting 2 points. Okay, again, this one involves lots of knowledge from what we've been doing. Now, looking at this formula here, what formula is that? And if you said point slope, y minus y sub 1 equals m times x minus x sub 1, you are correct. So what we want to do then is we have the slope, and we have one ordered pair that they're asking us to plot. Now, when an equation is in point-slope form, we ought to be able to pick out the y-coordinate and the x-coordinate. Now, if you said it was a -6 and a -5, that would be incorrect. Now, due to the negative signs in the point-slope form, it's the opposite signs of what you see here is the actual point. So, the opposite sign of this is a 6, and the opposite sign of this is a 5. So that's our point, 6, 5. So 6, 5 is this point right there. Now, that's the first point that you'll put in there. Now, you still need to put in one other point. Well, what's the slope then of this? Well, we said the slope is what's in front of the second set of parentheses there, and that is -4. Now, -4 is a -4 over 1. So we said we could go over 1 here and up 4 and get this point. That would have been satisfactory. Or you could have gone over 1 to the right and then down 4 to get this other point. So we've done this one or this one. And once you do, you have this example correct. Moving on, here they're asking determine the slope and the y-intercept. Well, this is in standard form. ax plus by equals c. Well, by solving for y, we can put it in slope-intercept form. Y equals mx plus b. When it's in this form, we can pick out the slope and the y-intercept. So we have here, let's go to our whiteboard after we write it down, 8x plus 6y equals a -24. So we're going to transpose the x term, so we have 6y. This now becomes a -8x on this side and a -24. Divide everything by 6. This becomes y equals. Now we need to simplify this. This is going to be a -4/3 x minus 4. So this is now in slope-intercept form. So our slope is a -4/3. And our y-intercept, we have to write it as an ordered pair, 0, -4. That's in the form 0 minus, or 0, and then a b here. 0, b. All right, let's see what they have. All right, so they have this for the slope. See, they didn't simplify, so they took off just 1/10 of a point. This is the slope, and then this is the y-intercept. They had that right. Many times students will just put -4 there. They'll count it wrong. I give partial credit for that, but it's better to get the full credit. Now I'll leave the writing up there because that'll help us with the graph. So what is our y-intercept? Well, our y-intercept was a -4, which is right there. And our slope is a -4/3. So we said go over 3 for the x to the left. 1, 2, 3, right there. Mentally put a dot, and then you go up 4. 1, 2, 3, 4. And lo and behold, that happens to be the x-intercept. So that would be the second point from this. Now, you could have made a t-chart, but again, graphing from the slope-intercept form was one of the skills we're working on. Plot your y-intercept, then plot your slope. Okay. Now, for this one, they're asking us, with our knowledge of x and y-intercepts, and we've given you this special t-chart, which we call the x and y-intercept t-chart. So there's our formula. If x here is 0, our y is going to be a -2. We're going to divide both sides by a -3. 6 over -3 is a -2. Now, if y is 0, we're just going to divide both sides by 6, and we get a 1. So what is the x and y-intercept on a graph? Well, 0, -2. We have it here, and we have it here. But what is our x-intercept? It's a +1 there. So our answer then is letter C, using our understanding of the x and y intercepts. Now, for number 11, we have systems of equations, and there are 2 equations, and we're looking to see where would they intersect. Well, it looks like right there, which is 7 and a -6. Now, if we put these values into these 2 equations, they would make both of these true. So this is the solution, and that's all they wonder, picking out the correct point of their intersection. Now here they're asking us to square a binomial. Now there is a special way, or you could have write it again and just FOIL it. We'll use the special way. Square this term. That's 49x squared. Multiply these 2 terms together. That's 35x. Double it. That would be 70x. Now, square this other term here. This is a +25. And this person had it correct. Now here they're giving us a system of equations, and let's write them over here. So 4x plus 2y equals a -24. And this one is going to be 3x plus y equals a negative 16. Now we're looking to solve for this equation to see where they might intersect. And the protocol for it is to, let's go to a whiteboard. Do something where we could either use substitution or elimination. I'm going to use elimination, where we're going to multiply this equation by something so the y's will cancel out. Now, what can I multiply this by so the y's would cancel out? And if you said a negative 2, that is correct. Now, as we do this, here the 2's cancel out, and I end up with a negative 2x. Do the subtraction here, and I get 8. Now I'm going to divide both sides by a negative 2. I get x equals negative 4. And let's go back to our whiteboard. And there is x is a negative 4. Now, once I have found one of the values, I then can go to either equation. I'm saying x is a negative 4. Let's go back to the whiteboard and use this equation here. So negative 4 times 3 is negative 12 plus y equals negative 16. And I add 12 now to this side, add 12 to this side, I get y equals negative 4 also here. So I had a little float call there, but there is then the ordered pair, the point of intersection. Now, how many solutions do we have? If we have just one point of intersection, and that would be one solution, that's what you would click. Now, if you had something that looked like this, just to go over these, we had like 0 equals 4. Is that a true statement once we did our elimination or substitution? And the answer is no. Then this would be one that the lines would parallel and it would be no solution. And how about if you had something like 4 equals 4 or 0 equals 0? These are both true. Well, in those cases, the lines are actually parallel lines, and there would be an infinite number of solutions. So again, the work supporting what you've done is what's needed to get full credit for something like this. All right, let's go on. Now, for something like this, they're asking us to find a missing coordinate. So a T-chart might be useful, help organize your data. We have the x-coordinate is 2, so what would the y-coordinate be? Well, if our x is 2, this is going to be 2 times 5 is 10, plus 5y equals 18, just substituting. Transpose the 10, becomes a negative 10, so this is 8. So 5y equals 8, divide both sides by 5. Y equals 8/5. And this person had that correct. Well, in a similar way, we now have the y coordinate as 3. What will our x be? Well, 5x. Now, 3 times 5 is 15, equals 18. Again, transpose this. This becomes a 3 then, once I subtract 15 from both sides. Divide both sides by 5, I get 3/5. and that's what you would put there. Okay, so a little bit of algebraic skill. Now, for something like this, we have y equals, I'm going to write 1x minus 2. So it's in slope-intercept form. So what's my slope? Well, 1 over 1. And what's my y-intercept? A negative 2. So I would put a dot at negative 2. And I would go over 1, up 1, and put a dot there. Or I could go over 2, up 2, put a dot there. And there's an infinite number of points along this line. So again, using a skill we've worked on. Now, for something like this, working with exponents, anything to the 0 power is 1. So this is 1. And 1 times 9 squared, which is 81, is 81. Now, this person didn't simplify, which they're asking us to do. So again, they lost 1/10 of a point. Again, following their instructions gives you full credit. Now here they're asking us to find the slope. Well, the formula for slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, working that out, we get a 7 minus a minus 3 is a positive 3, and then a negative 1, and then in the formula there's a negative, so another negative 1, adds up to 10 over negative 2, which equals a negative 5. And that person had it correct. Now, just a few. Now, for something like this, we're going to need to carefully write it out and substitute. So 0.07, and what is t? T is 6 hours, and that is to the 4th power, plus 0.5, t is still 6, but now this is to the 3rd power, plus 4, t is 6 to the 2nd power. And you're asked to round to the nearest whole number. So again, knowing how to put this into your calculator and getting this for an answer is critical. But having the work to show what you're doing is important as well. All right, let's go on. I recall where students had one like this incorrect, where again, it's very similar, 0.07. But now what is t? T is 2 days, but they want this in hours, and they're telling you it's 48 hours. That'll be raised to the 4th. Raised to the 3rd. Raised to the 2nd. Now notice, this is quite a big number, many more hours. Protozoans are growing like crazy here. All right. But again, put it in your calculator to see if you get the answer. Again, you want a protocol for doing this, so let's do it. Negative x to the 2nd plus 5x minus 3, and then we're going to multiply it by this. We're going to use the long way of doing it. And I'll go to the whiteboard. So negative 3 times negative 3 is a positive 9. 3 times this is a negative 15x. Negative 3 times this is a positive 3x squared. Now, 3x times this is a negative 9x. You're lining up like term columns. This times this is a positive 15x squared. Now here we're multiplying, so we have to involve the exponents as well. So 3 times this is going to be a negative 3x to the third. Now you've completed the multiplication. This is addition. So negative 3x cubed plus 18x squared. Here the exponents don't change, the variables. This is a negative 24x plus 9. Going back, we check it out here. I can see it in the background that we are correct. Let me just clear that up, and that is good. Again, you want a protocol to do it. Let's go on. All right, for something like this, working with exponents, simplifying the top, this is going to become x to the negative 6, and our base is x to the negative 2. Now we want positive exponents, so remember there's a 1 up there that we'll leave up there. We'll bring the negative 6 exponent down, crosses the division bar, becomes positive. So I have a negative 2 and a positive 6 gives me x to the positive 4, which is what the answer is. Now, as we get to the last one here, again, they want us to write this information into slope-intercept form. So there's our y. Our slope is a negative 3. We have to put the x in. But now we're going to write it in the y-intercept form, the b, which is a negative 3. So there it is. Now they then want you to take this and then graph it. So let's use that graph that's here to show how it's done. There's our y-intercept, negative 3. Our slope is a negative 3 over 1. So we said go over 1 to the left and then up 3. And there's our other point, and that completes it. Now, again, there's a couple of things we didn't review, but I think we've covered it like in point slope form. Let me just do one like that here. Now I'm going to suggest that we use this point here. So we need to find the coordinates of that point. So that's going to be a negative 3 and then a positive 6. Now if they said write this equation in point slope form, point slope form was y minus y sub 1 equals m times x minus x sub 1. Let's go to our whiteboard for this just extra one here. We'll clean that up a little bit here. Okay. Well, there's our formula. So y, now what's our y coordinate here? Well, it's 6. So we're going to put that in there, but negative's in the formula. So it goes in a sense as a negative 6. And our slope we know is a negative 3. And then it's y, I should say x here, get carried away. Now minus is in the formula, but our x value is a negative 3. So minus a negative 3 would make this a positive 3. So we've taken this equation, picked out a point along the line, and wrote it in point slope form. So again, if we wanted to pick the point out of that, the ordered pair, for our x, it's the opposite sign, a negative 3. And for our y, the opposite sign, a 6, which we knew, and we already had the slope. Okay, this will wind up this review. It ran, again, a little long. Remember, You have 75 minutes to take it.